Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present for our group project which is we got an industry education. First of all, my name is Nur Shazana binti Abdul Malik and this is my group's member.
My name is Nur Hidayah binti Muhammad Zaki.
My name is Nur Farisha binti Azizi. For our introduction, our project focused on developing a student management system tailored for the education sector. We aim to efficiently maintaining academic record, optimizing workflow, and improving data accessibility. The system highlights two key components. One of it is linked list-based system, which use a singly linked list for dynamic and efficient management of student record, enabling operator like adding, removing, updating, and searching student record. Then we have queue-based system, which follow a first-in, first-out approach to handle order sensitive tasks, such as inquiry, decree, and searching student attribute. Together, this system streamlines data management while ensuring adaptability and reliability.
Okay, next we have an input file, which is we store at least 21 person into this input file. And then we have for object class, we have attribute student ID, name, gender, age, grade level, major, CGPA, address, contact number, email, and status. Status, which is the student is an active student or already graduated. Next we have a node class. And then our linked list, we have an option to add a new item at the front of the list, add a new item at the back of the list, remove a node anywhere in the list by value, remove the first item from the list, determine the size of the list, and check if the list is empty. And next is display all element in the list and get the head node for traversal purpose, where we can traverse any data in the input file, in the list, and then retrieve the next node given the current node. Okay, let's go into the application class for linked list. We start as a student LL. First, we have a 5 process, which is to display, to add a new student, remove student using ID, search student by ID, and update student detail. Let's go to the first process, which is display student, display all student. We use formatting the output, and then this is the example. This is the coding that to display the student. This is an example of output to display a student. User need to enter the choice, which is number 1. And then it will come out like this. It will show every student in the input file. Next, the second choice is add a new student. The user need to enter everything about a student, the detail, ID, name, gender, age, and many more. And then the student will add into the linked list, and also the data will also added into the input file, will be updated lah. For the example of input, we enter choice number 2, and then the user will enter the ID, name, gender, and many more, and the list will be updated at the front, at the above. Okay, next we go for choice number 3, which is we remove the student. If we want to remove the student, user need to enter an ID that they want to remove. This is the code for user for remove a student. This is an example for user to enter choice number 3 and enter ID to remove, for example S20. And then in the list of data, there is no S20 anymore. Next is the process to search a student using an ID. User will need to enter ID to search, and then we will give an output using a formatted output. For example, this is the sample input. user enter choice number 4 and enter ID to search is S19. And then the output will show S19 only. Next is choice number 5, update student ID. This is the code to update student ID. User can only update new email and new CGPA. And this is an example for user to input. User will choose number 5 and then enter ID to update, which is S19. New email and new CGPA only can be updated. Other data cannot be updated. And this is the updated data. Low carrying. The CGPA will change to 2.98 and the email will change to. Okay, next is exit, which is case 6. Choice number 6. If the user enter number 6, the system will exit. Next, we go for second application, which is student queue. First of all, this is a coding for queue, node queue, queue list, node front, node rear, and thread size. Still add data at the end of the queue. Remove data at the front of the queue. Pick at the front of the queue. Check if the queue is empty and get the size of the queue and display all elements using a consumer key. This is our menu, which is still have 5 process. Add a new student, remove a student, display all student in the queue, search for a student ID, update student information. First choice is add a new student. This is the coding for a user to enter. We have user need to enter ID, name, gender, age, and many more. And then student, the data will enqueue in the queue, which is using student queue.enqueue, since the object name for queue is student queue. And then the data will also save into an input file. Next, this is an example for add a new student. User will enter a choice number 1 and they need to enter the details about a student. And then this is the output, and the data after is student. The new student will be added at the latest data. Next is choice number 2, which is remove a student. If we want to remove a student, just enter a choice number 2 and then the student will be removed at the top. Okay, for choice number 3 is display all student. This is the code to display all student. We use manually iterate and we store temporary into a temporary queue. Okay, this is an example for input to remove to display all student. User need to enter number 3 and then this is the output. The system will show everything in the input file into the system. Okay, for process number 4 is search student ID. This is the code to search student ID, and then this is an example for input. User will need to enter choice number 4 to enter student, to search a student using an ID, and then user will enter a student ID to search. This is the output for student ID that you search. Okay, next, the last process is update student's ID. This is the code, and for example for input is user need to enter choice number 5 and enter student ID to update. For example S23, and then student will enter only change CGPA and email also. Okay, this is the data after updated, which is it changed CGPA and email. And the last choice is exit. This is if user enters choice number 6, it will exit the program.
The last one is the conclusion. when choosing the best data structure largely depends on the complexity of the applications and the operational needs. Queue is a great choice if the requirement is to manage students in strict order that handles students in the first in, first out order, where the first adder is the first to be processed. Then easy operations such as adding to the back end queue and removing DQ are straightforward and efficient. However, there are limitations to queue where queue cannot access or modify elements in the middle, making it unsuitable for tasks needing frequent changes. In comparison, linked list provides better adaptability and flexibility. Linked lists support dynamic adjustment that allows adding or removing elements at any position, perfect for changing the size of the student list. Next, linked lists provide more features such as support searching and updating elements, making it great for applications that need frequent changes. However, linked lists are a little bit more complex than queue because linked list needs more memory for pointers. In summary, linked list is an ideal choice for better long-term efficiency and adaptability despite its complexity.